Neil deGrasse Tyson explains faster-than-light interstellar travel. Tyson unravels the secrets of faster-than-light interstellar travel. In this video, prepare to have your mind stretched and your imagination ignited as Dr. Tyson delves into the realms of theoretical physics, exploring the possibilities and limitations of warp drives, wormholes, and the fabric of space-time itself. Physicists are actively investigating the possibility of achieving faster-than-light travel, particularly through the concept of warp drives. The aim is to develop a means of interstellar travel that would allow humans to traverse vast distances between stars more easily. Warp drives involve manipulating space-time by compressing the space in front of a starship while simultaneously expanding space-time behind it. This idea is based on Albert Einstein's theory of general relativity, which explains the connection between mass, energy, and space-time curvature. Miguel Alcubierre, a physicist, came up with a radical idea in 1994 for a technology that would make it possible to travel faster than the speed of light. His idea was the warp drive, which would involve bending the fabric of reality in order to get around the universe's maximum speed limit. Although it was an intriguing idea, so intriguing in fact that NASA had been conducting research on it at the Eagle Works laboratory, Alcubierre's proposal contained issues that appeared to be insurmountable. Now, physicists based in the United States named Alexei Bobrik and Gianni Martir have published a paper that has resolved many of those issues and has generated a lot of buzz. However, despite the fact that Bobrik and Martir have been successful in removing a significant amount of the mystery surrounding warp technology, their research indicates that beings like us will not be able to achieve faster-than-light travel for the foreseeable future. There is, however, a silver lining to this cloud, and that is the possibility that warp technology could have far-reaching applications beyond space travel. Over the entirety of the universe? The theory of general relativity, which was Einstein's crowning achievement, is where the history of warp drives begins. The equations of general relativity capture the way in which space-time, the very fabric of reality, bends in response to the presence of matter and energy, which, in turn, explains how matter and energy move about. Space-time is the very fabric of reality. Interstellar travel is subject to two restrictions as a result of general relativity. To begin, it is impossible to accelerate anything further than the speed of light, which is approximately 300,000 kilometers per second. Even if we traveled at this mind-boggling speed, it would still take us 4 years to get to Proxima Centauri, the star that is the closest to our sun. Second, the passage of time would appear to move more slowly on a clock aboard a spaceship traveling close to the speed of light when compared to a clock on Earth. This phenomenon is known as time dilation. Assuming that this acceleration is maintained at a constant level, it is now feasible to travel between the stars. In one's lifetime, it is possible to travel the equivalent of 150 light years to get to a star that is very far away. The catch, however, is that by the time one gets back to their home planet, more than 300 years will have passed. A new ray of hope. Alcubierre entered the picture at this point. He contended that the math of general relativity considered twist bubbles, which are locales in which matter and energy are organized so as to twist space-time before the air pocket and extend it to the back so that permits a level region inside the air pocket to travel quicker than light. These warp bubbles can only exist in regions where matter and energy are arranged in such a way as to allow space-time to be warped. It is helpful to think of space-time as being analogous to a rubber mat in order to understand what is meant by the term flat in this discussion. The presence of matter and energy causes the mat to curve. Imagine putting a bowling ball on it to get an idea of what this looks like. There is nothing more to the concept of gravity than the tendency for objects to roll into the dents created by celestial bodies such as stars and planets. A region of the mat that is devoid of any detail is known as a flat region. In addition, this kind of drive would steer clear of the unpleasant effects that time dilation has. It is possible to travel back home after making a round trip into deep space and still be greeted by one's closest and dearest friends and family, a peculiarity of space and time. How does Alcubierre's device work? Because mathematics is so difficult to understand, discussions here frequently rely on analogies. Just picture a rug with a cup sitting on it. You are currently sitting on the rug, but you need to get to the cup. You could either walk on the rug or pull it closer to you with your hands. Using the warp drive is similar to pulling on space-time in order to get closer to your destination. However, there are limitations to using analogies. A warp drive does not actually bring your destination closer to you. Because of this, the distance you have to travel will be reduced. When the drive is turned on, there will be a smaller amount of rug in between you and the cup. The suggestion made by Alcubierre, while sound from a mathematical point of view, is not easy to comprehend from an intuitive standpoint. The work that Bobrick and Martyr have done will likely change all of that. Errors made by the starships. Bobrick and Martyr's research demonstrates that a warp drive must consist of a shell of material that is in a constant state of motion and encloses a region of space-time that is flat. The properties of the space-time region contained within the shell are altered as a result of the energy of the shell. This may not sound like much of a breakthrough, but up until now, it was unknown what warp drives could possibly be in terms of their physical makeup. According to their research, a warp drive can be compared to a car, which comes as a bit of a surprise. A flat region of space-time is enclosed within a shell of energy that takes the form of matter and is known as a car. The main distinction is that getting into a car does not hasten the aging process in any way. On the other hand, this is the sort of thing that a warp drive could accomplish. Bobrick and Martyr demonstrate a method for using Einstein's general relativity equations to find spacetimes that allow for arrangements of matter and energy that would act as warp bubbles by utilizing their straightforward description. This method can be found in their paper. This provides us with a mathematical key that can be used to locate and categorize warp technologies. The results of their work managed to solve one of the fundamental issues that plague warp drives. The use of negative energy in Alcubierre's device is what allows the equations to be balanced. However, we have not yet found any sources of negative energy that can be used in the real world that are viable. Worse than that, the requirements for the device created by Alcubierre in terms of negative energy are extremely high. As per a few assessments, all of the energy in the noticeable universe would need to be utilized, albeit later exploration has cut the number down a tad. Both Bobrick and Martyr demonstrate that a warp drive could be constructed using either positive energy, also known as normal energy, or a combination of positive and negative energy. Having said that, the energy demands would still be extremely significant. If Bobrick and Martyr are correct in their assumptions, then a warp drive is the same as any other moving object. After all, it would be subject to the universal speed limit enforced by general relativity, and in order to accelerate, it would require some kind of conventional propulsion system. The bad news just keeps on coming. There are a wide range of kinds of twist drives. However, a large portion of them can change the space-time inside the vehicle in one explicit manner. This way involves slowing down the clock of the passenger, which is exactly the way that a journey into deep space presents difficulties. In their research, Bobrick and Martyr were able to demonstrate that certain warp drives have the potential to travel faster than the speed of light. However, this is only possible if the warp drives are created while already moving at that speed, which is of no assistance to regular humans who have aspirations of engaging in interstellar travel. And that's all for today's video. We will see you in the next one. If you want to stay updated, then hit the subscribe button.